Good day, young solvers, well wishers. Yeah, this is electrical power for ND1 actually. Yeah, this question that we're solving right now, you can review it and check for it. If any of the questions it seems that is not that correct, you can put that in the comments below. Let's look at it. And any question you have before the end of this session, make sure you ask. Hello, friends. Hello, friends. Well wishers. Today we're going to be looking at electrical power one solution. For those that are saying, oh, it has been long, guys, Mr. Shea solve a past question or want to give us answers on this YouTube channel. Today, I'll be using the opportunity to do so right now. Let's look at this 2017, um, 2018. Um, there's some past questions on 2017/2018 that I would like us to look at. If you're able to solve this past question very correctly, you should be 80% sure that you can solve your electrical power one on your own. This question, we're looking at it now. Okay. Then this is a handwritten with the aid of a diagram explain the working principle of a gas turbine power plant. Now this is how a gas turbine power plant diagram looks like. First, we have a combustion chamber, then we couple it with the gas turbine. Then we have the gas, the main prime mover here is the gas turbine. Is the prime mover the most important thing in this diagram. Now, at the gas turbine, the fire that is being given by the combustion chamber, the heat that's being transferred from the combustion chamber to the gas turbine, is being taken to the alternator, where the alternator will drive it from its mechanical power, which it was, to electrical power. Then the light is being supplied. Okay, let's look at it. A gas turbine power plant is the type of generating station that use gas turbine as the prime mover for the generation of electrical energy. The air combustion chamber, when heat is added to air, thus raising its temperature, it is added to the compressed air either by burning fuel in the chamber or by the use of air heaters. The hot and pressure air from the combustion chamber is then passed to the gas turbine. Can you see that? Where the heat is being transferred to the gas turbine. The gas turbine and that's now expanding and gains an initial process of mechanical energy there. Now the mechanical energy is now transferred to the alternator, which converts mechanical energy into electrical energy. Okay, let's look also at the head of a diagram, explain the working principle of steam power plant. And this is how a steam power plant looks like. Okay, we have the boiler. Yes, we have the boiler, the mill, the stock, the water purification system, condenser, ash system. Now let's look at this. Alternator is at this point here. Some of you may be wondering, oh, how come does this diagram look so hard to draw? Let me tell you, it's very, very, very simple. I draw it offhand. You too can do better. What you're going to do is that you have to practice this diagram like 3 to 4 times. Draw it the first time by looking at it. The second time, you should be able to do it without the need of you looking at the diagram at all. Okay? So after doing that, you'll be able to get a diagram at the fourth time when you're doing it on your own. Even though if you're not that perfect with it, you can still do more in the fifth or sixth or seventh time. Make sure that you never give up. At this diagram now, when you do it, you should be able to have a very full mark. The explanation is very simple as the first. The steam power station is a type of generating power station that converts heat energy to electrical energy. The steam is produced in boiler by utilizing the heat of cold combustion. The steam is then expanded in the prime mover. The prime mover there is the steam power turbine. The turbine in any station is the prime mover of the electrical power station. Now, and it's condensed in a condenser to be fed into the boiler again. The steam turbine drives the alternator, which converts mechanical energy to electrical energy. Now look at this question. What's the maximum length in kilometer for a one-phase transmission having copper conductor of 0.775 centimeter square, cross-section over which 200 kilowatts at unity power factor and 3,300 volts are to be delivered? So these are the answers to it. You can go through it. If you have any question, you can be sure.
The question there is
So
the
this
question
is
before question
you can
2,
go through it. If you have
where
any
you have
question, you can be sure to
a
ask me.
single phase AC
I will
distribution 2
always deliver
kilometer
your answer
long
on
supplies
time.
a load of 120 ampere. So
The
be
final
sure
answer
to
there is
read it over and over
13.59
again so as to
kilometer. If you have any
understand the solve.
question there, let me know. This question will surely be asked and you won't miss it. So this is it. I want you guys to look at it very well. At this point here, you can see it here. This is the impedance of distribution per kilometer, R plus J. That place there now. Let's look at it. The impedance of distribution, that is ZAC. Impedance there is the Z. Z there means impedance. R there is resistance. So those are the things we are making use of there. So now we have it. Those section A and section B and section C, they actually means the the pole they make use of there. So at AC, at AC, we're going to calculate both I1 and I2 because we're going to look at the current that flows through A and current that flows through B. So at this point now, we are looking for independence per distribution per kilometer, which is ZAC and ZCB. Okay, from ZAC, the resistance there is 0.05. For ZCB, the resistance to there is 0.05, and our S there is 0.1 and 0.1 for the other two, the same. So that is why we have it for R plus JS, which we have those figures for, which you can see there now at this point here. So now, at here, taking the load current at point B, we have there to be I2, or the load at point C first, we have it to be I1. So at point C, we have current I1. At point B, we have current I2. Okay. This is point C having I1. This is point B having I2. So now we're going to calculate it. The way we calculate it for I2 is I1 into bracket cos theta 1 minus j sin theta 2. For I2, we say I2 into bracket cos theta 2 minus j sin theta 1. Theta 2 too. So for load current at point B and load current at section point A2. So we have for cos theta equals 0.8. Now, while solving this, cos theta 2 that was given to us in the diagram is 0.8. Okay. For cos theta 1, what was given to us is 0.9. You can see there, 0.9. Okay. So while solving it, we'll make use of that. Like look at now. For cos theta 1, we make use of cos theta 1 to be 0.9 and j sin theta to be 0.4. Sin theta 1 to be 0.4. For the other one, cos theta 2 is 0.8, sin theta 2 is 0.6. While the I2 of the diagram is 120, the I2 of the first one is 80. So after that, we solve that. First of all, what we do is that we look for the impedance. Later, we look current in section CB. As you have said, we look for the current I1, I2 here. I2 that is in current in that is 96 minus J72, like we have done earlier. Look at it here. Current in I1, can you see it? I2, 96 minus J72 at this point here. Current in section CB, as you have said, we have only, we look for the current I1, I2 here. I2 that is in current in that is 96 minus J72, like we have done earlier. Look at it here. Current in I1, can you see it? I2, 96 minus J72 at this point here. What we're going to be looking at now is the voltage drop. So what we did first, that we look for the impedance. The after impedance, we look for the current drop in A, current in B, and we look for, after that we look at the current in each section AC and AB. We have seen CB. We have seen how we do solve that. Then later we look for the voltage drop. Remember that in voltage, to calculate voltage in Ohm's law is V equals to IR, but here we're going to be using V equals to IZ. The Z here is our impedance as section, maybe AC or CB. For instance, look at our impedance per kilometer. Look at the other CB for impedance there. So having that, we can use that to solve our voltage drop. F equals to IAC ZAC. IAC there means the current at section AC, and current at section CB is the ICB. So you can solve that, you multiply, you have your answers to be exactly what I have here. If you don't have it, you can still come back to this video to check it very well. This is to help you guys to understand this topic very well. In case of if you guys did not understand any explanation, just as to make endeavor that you guys have good grade and good understanding matters a lot. Good understanding matters a lot when passing your exams. So let's continue. Voltage drop over the distribution. Now the voltage drop over the distribution, let's calculate the total voltage. So we add both the VAC and VCB, what we have gotten earlier. You understand? So with that, we're supposed to add up these two. Then adding up, got this. Then after that, we'll look for the magnitude of the voltage drop. The magnitude of the voltage drop, after we've gotten the total voltage, we'll have that to be V squared equals to R squared plus IM squared from Pythagoras theory. Then when we square those together, our final answer should be 31.30. Now, there are some questions we'll be dealing with actually. It says, explain briefly the following terms in overhead transmission line. Okay. Now, what is short transmission line? Short transmission line is said to be short when the distance about 50 kilometers and the line voltage is less than 20 kilovolts. Then when you have any line that is giving a light or passing the current there is, or the voltage there is less than 20 kilovolts, and the length of the line is less or to up to 50 kilometers, then we say it is short transmission line. For a medium transmission line, it must be ranging from 50 kilometers to 150 kilometers, and the voltage there should be rising from 20 kilovolts and less or up to 100 kilovolts, though it cannot be up to like 100 kilovolts anyway. The next one, we have the protection system. This is the art of protecting the circuit against overload and short circuits. Okay, the next one we look at voltage regulation. Voltage regulation, it has to regulate the voltage in a kind of place that it makes the wave voltage very useful for what is you are actually using it for. For instance, it will step up the voltage to the requirement of what the equipment needed to or for. E.g., like stabilizer, we use stabilizer for voltage regulation. Explain general construction of a three-core cable. Now, for a three-core cable, we have the conductor, paper insulator, lead sheet, bedding, armoring, serving. Now, the conductor is the wire there, the real wire in the diagram. Now, the wire there is called conductor. So people do mistake that metal ring there. The actual metal there is the one that passes the current from one place to the other, and it is called the conductor. Now the paper insulator, the work of the paper insulator is to cover the conductor from shocking anyone that will hold it. So it is covering the conductor to prevent external shock of or and it prevents the electricity in the conductor to go to pass through so that anyone that touch that conductor at that particular time will not be shocked. You get that? The lead sheet of the lead sheet is that it is the part that protects the paper insulator. The bedding helps to prevent the lead sheet from rusting so that the lead sheet will not rust. While the armoring is the part protecting the bedding. While the serving is the outer part of the insulator, which protect the cable from mechanical damage. Just like if you rough handle that cable, it will not get destroyed. It will not be damaged, no matter how your hand is as hard as. You cannot rough handle it with your hand and it will start peeling or doing one thing. That is the work of the serving. So all these things work for each other, just to make sure that your cable is a very good one used in your place of work. And now define a fuse and state the component part of a fuse with suitable diagram. What is a fuse? A fuse is a short circuit of metal insert in the circuit which met when excessive current flows through it and just break itself. Okay. Um, Inside that cycle there, we have the filling powder, outer element, fuse link contact, cartridge, fuse element, base end plate. For instance, let me tell you now, when working with a fuse, the fuse only works once, it only has one life. And once it operates, what you have to do to make it to come back is that you have to go and replace the element. Just like you have to find the wire that they make use of there. So that the wire there is the conductor. If it is a house which the electrician that worked on that house make use of 1.5 mm wire, you should go back there and replace the element with that 1.5. If it's a place that they use 2.5, you replace it back with that 2.5, depend on the house. So that when there is overload or the current produced is not enough or too low or too high, it will be able to clip off or the element will burn so as to endeavor that your appliances don't get destroyed or damaged. So that is the make usefulness of fuse. But what they call a circuit breaker is much more better than that anyway. So define the following terms. We have the fusing current, the current rating, and the fusing factor. The fusing current is the current at which the fuse element will met or the minimum current at which the element will met and thereby disconnect the circuit protected by it. Yes, the current at which the fuse element will met or the minimum current at which the element will met and thereby disconnect the circuit protected by it. It will help to at that fusing current at that particular time that current that that the current will actually met or that element there will met or that will disconnect it that an electrician will need to go and replace it. That is called the fusing current. At that point of electricity where that fusing element disconnected got met, that is what they call fusing current. Very simple. And the current rating is the maximum current the fuse will carry without it getting spoiled, without it deteriorating, is what we call current rating. Fusing factor is the ratio of the minimum fusing current to the current rating. It can be divided. It can be known as this mathematical way by saying the minimum fusing current is divided by the current rating. Fuse factor equals the minimum fusing current divided by current rating. Characteristics of fuse elements. We have the low melting point, e.g. tin, high conductivity, e.g. copper. Copper conducts electricity very well. We also have some other ones that conduct very well. We have low cost, e.g. lead. And we have state three types of conductor. We have the copper, aluminium, alloy, so many more. Yeah. Define circuit breaker and state four types of circuit breaker. Like we said, circuit breaker is a piece of equipment which can make or break a circuit manually or by remote control under normal condition. The four types of circuit breaker we'll be looking at is oil circuit breaker, gas circuit breaker, air circuit breaker, and miniature circuit breaker. I think the miniature circuit breaker is more common these days. State four differences between fuse and circuit breaker. Like I said, fuse only work in one time and the elements will be replaced. Circuit breaker work over and over again. Time operation is about 0.02 seconds, very fast. Time operation is about 0.5 seconds. Fuse elements can be tampered with when replacing. It cannot be tampered with. Fuse elements are always replaced after operation. No replacing of any elements. Like I said, in my place of work, while we were working, the place was making use of circuit breaker in the DB, you understand? So the socket that was connected to one of the circuit breaker in the DB, someone plugged his charger there, and the charger was somehow faulty to the extent that it caused a spark in the socket. What happened that the charger spoiled, and the socket also stopped bringing light at the indicator. So a student has a question that is the socket damaged also? The reply was no, that the circuit breaker in the DB will rather trip off than the socket to spoil. And truly, when we got to the DB and we turn the circuit breaker back to its normal position, actually the socket started working. It shows how useful the circuit breaker is. And the circuit breaker elements don't need to be replaced, but in fuse, you have to always replace the fuse element after each use. Okay, list four types of insulator and sketch any two type. We have suspension type, pin type, shackle insulator. You should go and look for the fourth one. This is how a shackle insulator looks like. Right, you can tell us your number four insulator. I will not say it. Tell us the fourth and any other suspension, any other type of insulator you know. Put it in the comment box. Yeah. Examples of insulator is different from types. Remember, examples are like we have uh, we have dry wood, porcelain, glass, mica. So those are the examples of insulators that are different from types. You understand? One short note on insulating material. Insulating material, the material which does not allow electric current to pass through them. Anything that does not allow electricity to pass through them is what we call as insulator. Okay. Explain the difference between feeders, distributor, and service main. So the question that asked there. So if you can answer it, you have a good pass mark. So feeder is a device that serves as a protection for the transformer and the distribution line. Distribution means this is the transmission line that comes out of the transformer, usually be on low tension poles and carry a voltage between 220 volts to 415 volts. Service main, this is the mains which is used to tap from the distributor main to the consumer. Define protective relay and draw a typical relay circuit. Protective relay is a system used in protecting an electric circuit. Okay, this is how a typical relay circuit look like. That is DC source. We have the three coil, the circuit breaker. That three coil, that is where the thing trip up. The current transformer, the relay coil, and the fault. Okay, and this particular, that's where it is connected to the DB. I hope you guys have seen a DB before. If you have seen a DB, you are able to see like the circuit. Okay, list and explain four requirements for power system protection. A good power system protection should be reliable, stable, it must be timely, it must be selective. Reliable in the kind of place that it must always provide a function when required to avoid damage of equipment, lives and property. It must be stable. The protection system must not react to faults in neighboring zone and shall not react to non-fault situation. You should not just be tripping off and be doing anyhow when there is nothing actually having fault or problem in the house or in your equipment or electrical installation. So it should always operate at its best. And you should not go and do the work we did not send it to do. It should be always efficient, timely. It must provide that protection at that particular time there is any disconnect, there's any problem in the electrical installation. Selectivity on the affected point, it must always display. Not that one socket will be having fault, it will be offing the AC. No. Not that one water heater will be having fault, it will be offing the pump. No. That is, it should be selective to the exact point is having the fault. So if it's socket, you should go and trip up the socket circuit breaker. Okay, state the purposes of protection system: to protect equipment, to protect against overload, to improve system stability. You can also give us one more example of what it could protect on the comment box. What a circuit breaker can protect or what a protect system can do. Okay, list 4 types of protection. We have this here. So we actually we are going to the end of electrical power 1 2017/2018 EEC 122. If you can solve this, you are going to have some edge over your mate. So I advise you to also solve like more questions. In this channel we will putting more dropping out more solutions like this or better than this in the future, and we would like you, for you to be able to get them, you have to subscribe for YouTube to always give you a quick reminder instead of you trying to get us. YouTube will make it very easier for you. And for those who have it hard time to read on their own, this is a very good advantage for you. You can make use of this and you'll be surprised how you're going to make good grade. Remember that for you to make good grade, you have to have a good understanding. Okay. And any question you have, you can inbox us. Like I said, my name is Sheyi. I'm from electrical department. And I finished with distinction. So if you have 1 or 2 things I can help you with in kindness of 7, I'm a free man. You can always bring it to me. Thank you. God bless you.